The first case, when force and displacement are parallel to each other, it is the dot product of two vectors. Force and displacement are vectors. It is not simply the power. It is horsepower of the engine. Potential energy of the body should be equal to kinetic energy of the car. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. A new day, new thoughts, a new session. What is this session all about? We will be solving numericals from the chapter Work, Power and Energy. The first problem, students. The problem says a force of 600 Newton. There is a force of 600 Newton displacing an object through 2-meter distance. A force of 600 Newton displaces an object through 2 meters. Find the work done if the force and displacement are parallel to each other and are at right angles to each other. So, in two cases, we have been asked to calculate the work done. The first case, when force and displacement are parallel to each other. Second case, they are at right angles to each other. So, what is given? Force 600 Newton, displacement 2 meters. Now, in the first case, we consider force and displacement are parallel to each other. So, in the first case, I am calculating the work when force and displacement are parallel. So what is the expression for work done, students? We know W is vector F, vector S, cos theta. Why W, work done, is not a vector? It is a scalar because it is the dot product of two vectors. Force and displacement are vectors. F dot S, dot product, always gives a scalar. What is theta? F and S are parallel. So theta is 0 degrees. So cos 0 is 1. Or F equals, this is 600 into S is 2. So work done is 1200 joules. So in the first case, when force and displacement are parallel, work done is 1200 joules. Second, force and displacement are perpendicular to each other. In the second case, I'm computing work when force and displacement are perpendicular. Again, W is vector F, vector S cos theta. Now what is theta? They are at right angles, perpendicular. Theta is 90 degrees. So cos 90 is 0. So work done in this case is 0. See, just knowing the concept, getting the angles, I have solved the given problem. The next one, students. The problem says, a pump is used to fill a tank 6 meter into 3 meter into 2 meter in half an hour. So we are intending to fill a tank of 6 meter into 3 meter into 2 meters in half an hour. Keep in mind, ardha ghante, half an hour. If the average height to which water has to be lifted from the well is 110 meters, average height from which water has to be lifted, I have to calculate the horsepower of the engine. It is not simply the power, it is horsepower of the engine. Now, the first thing, volume of the tank. I will first calculate the volume of the tank. 6 meter into 3 meter, which is 6 3s are 18. 18 into 2 is 36. So this is 36 meter cube. So this is the volume of the tank. So as the first step of calculation, I have calculated the volume of the tank. Now, mass of water that is lifted, M, mass of water that is lifted is volume into density. Density is mass by volume. So volume into density is giving you mass. So M is 36 into density of water, which is 10 power 3 kgs. So, volume of the tank is done. Mass of water is done. Next, work done to lift the water. How will I calculate work? F dot S. F is m into g. This is the height. So 36 into 10 power 3 into 10. So work done in this case is so many joules. So next we are calculating power. So power is work done by time. So this is 36 into 10. So this is half an hour, which is 30 minutes into seconds. So this is equal to 0. Into 10 power 5 watts. But it has to be in horsepower. So P is 0.216. 1 horsepower, 746 watts. So on computation, this is nearly 29 horsepower. So this is the horsepower of the engine. So the next problem. A lorry of mass 5 tons runs on a level track with the speed of 80 kilometer per hour. So there is a lorry of mass 5 tons, 5-ton mass, which is moving on a level track with a speed of 80 kilometer per hour. If the resistance due to air and friction is 80 Newton per ton, resistance friction due to air and friction is 80 Newton per ton, I have to find the horsepower of the engine. Now, first, I will calculate the frictional force acting on the lorry. The frictional force that is acting on the lorry. So this is 5 into 80, which is 400 Newton. So the frictional force on the lorry is 400 Newton. First, I will calculate the power. Force is known. Velocity is given. So power is force into velocity. This we have proved in our theory class. P is vector F dot vector V. Or this is 400 into velocity is 80 kilometer per hour. 60 into 60. So this is equal to 8.9 into 10 power 3 watts. Once I have calculated the power, again it has to be in horsepower. So power is 8 into 10 power 3, 746, which is equal to nearly 12 horsepower. So the answer is 12 horsepower. Step by step. Force. Power is the product of force and velocity. Conversion from power to horsepower. The next problem. Find the height from which a body of mass 50 kg should fall in order to have the kinetic energy of a car of mass 200 kg traveling at 10 meter per second. Now, mass of the body M1 is 50 kg. So this 50 kg is the mass of the body, and the mass of the car M2 is 200 kg. So first I will calculate potential energy of the body, which is mgh. And we all know m is nothing but m1. So 50 into 9.8 into h, which is nearly 490 h. Potential energy of the body. Now I will find kinetic energy of the car, mv square. This is half 200 into 10 square, which is 10,000 joules. Now by concept, potential energy of the body should be equal to kinetic energy of the car. So potential energy of the body should be equal to of the car. So 490 H, 10,000 joules, or H turns out to be 20.4 meters. So students, we see how numericals from work, power, energy can be solved easily. The next session, I come up with few more numericals. Until then, have a nice time. Thank you.